Hello everyone, welcome back to my math channel MathWeb. In this video, I will answer your question number 6 from Pearson Edexcel A-Level exam for Pure Math 4. This exam is taken in May-June session year 2024. Paper reference code is WMA 14/01. With respect to a fixed origin O, the line L1 is given by the equation R equals to I plus 2j plus 5k plus lambda into 8i minus j plus 4k. Where lambda is the scalar parameter, the point A lies on line L1. Given that magnitude of vector OA is given 5 square root 10, first part show that at A the parameter lambda satisfies this equation, 81 lambda square plus 52 lambda minus 220 equals to 0. This is the first part. Here R is giving you the position of any point on the line L1, like it will give you the position of point A, B, whatever the points lie on line L1, it will give you the position. And here it is always the starting point. This is called the starting vector, starting position, and plus here is the scalar multiple, and this vector is always the direction vector. This is the standard form of writing the position vector of any line. Got it? This vector is always a direction vector. It is giving you the final direction. You can write the vector OA because A lies on line L1, so this position vector will give you the vector of OA as well. Okay, so let me write that vector here. We can write OA vector as, better you write in column vector form. Here is lambda, and this is the direction vector. Here this one is 1, 2, 5, so you can write here 1, 2, 5, and direction vector is 8, minus 1, 4. 8, minus 1 and 4. And second thing, it is given that the magnitude of the vector is given as 5 square root 10. OA magnitude is given as 5 square root 10. Better you solve it, we can write as 1 plus 8 lambda. 1 plus 8 lambda. You can add the corresponding numbers. 2 minus lambda. And here 5 plus 4 lambda. This is vector OA. Now, if you write here the magnitude of this vector is given in the question, that is equals to 5 square root 10, implies that by using the formula of finding the magnitude of the vector, it is always equal to the square root of the component of I, 1 plus 8 lambda square, and then component for j, that is 2 minus lambda square, and the third component is 5 plus 4 lambda. So this is the formula of finding the magnitude of the vector. We take the squares of I component, j's and k's, that's it. And right on the side, right side is equals to 5 square root 10. In the next step, you can take square of both sides to get rid of the square root. If you take square of both sides, you get here on the right side, the answer will be 25 multiplied 10 is 250. Later we will write. Let us expand the brackets here. 1 plus 8 lambda square is equals to 1 plus the product is 16 lambda plus 8 lambda square is 64 lambda square. Now expand this bracket. That will be equals to 4, and the product will be equals to 2 times lambda. So it will be 4 lambda plus lambda square. Now expand this one. We will get here 25. And product will be equals to 10 times 4 is 40 lambda, and square of the last number will be 16 lambda square. And on the right side, solve it, we get the answer as 25 multiplied 10 is 250. Now collect the like terms. 64 lambda square and 1 lambda square and 16 lambda square. We add them together, we get here 81 lambda square. Now you need to add lambdas. Here 40 lambda minus 4 lambda is 36 lambda, and plus 16, 52 lambda. 1 plus 4 is 5, 5 plus 25 is 30. Then bring this one 250 equals to 0. Simplifying this one, we get the result 81 lambda square plus 52 lambda. Minus solve these two, you get the answer here 220 equals to 0. Let's go back to the question. Yes, it is exactly as required in the question. Okay. So we proved it. It is exactly as required. So first part is done for question number 6. Hopefully you understand it. Now next part. Hence, show that one possible position vector for A is this one. We already got the position vector here in form. This is the position vector of vector A. Position vector is the vector that is measured from the origin. OA is the position vector of A. Got it? So this is the position vector. Once you find the value of lambda, for sure you will get this result. One vector you will find this one and other, because from this equation we will get two answers for lambda. If you put one answer of lambda in this vector, you will get the result. And in the next part, find the other possible position vector. So you could find the other possible position vector for A as well. First, let us do this one. For B part, first part for this one, we will solve the equation, lambda equation. 81 lambda square plus 52 lambda minus 220 equals to 0. By quadratic formula, you could find the values of lambda. This is the easiest way, even though we can factorize here, but quadratic formula will work for you here, no problem. Quadratic formula works for everything. You can apply this one and you can get the result. Let me write the formula, quadratic formula, that is minus b plus minus b square minus 4ac divided by 2a. Just plug in the values here. B is 52, so it will be minus 52 plus minus, this will be 52 square minus 4, A is 81 and C is minus 220. Divide by 2A, 2 times 81. You will get the answer for the square root part, that is equal to 272. Minus 52 plus 272. Divide by 2 multiply 81 is 162. Like this you will get two answers for it. One will be, actually here is plus minus. One answer you will get like this, minus 52 plus 272 divide by 162. And other answer we will use the negative value, minus 52 minus 272 divide by 162. We have two answers. One answer is 110 divided by 81. This is the one answer for lambda, and other answer equals to lambda equals to negative 2. So we get two answers for lambda. If you plug in this value or that value here, for sure you will get the answer for the position vector of vector A. Because the fraction part will not give you this answer, because here are no fractions given in this vector. Therefore, we could use this value of lambda in the position vector, this value. Vector OA is given as, let me go back there, that is 1 plus 8 lambda, 2 minus lambda, 1 plus 8 lambda, 2 minus lambda, and the last one is 5 plus 4 lambda. 5 plus 4 lambda. Plug in the values of lambda here. Once lambda equals to minus 2, we will get the result. So it will be equals to 1, minus 2 multiply 8 is minus 16, and minus 2, this minus and that minus makes it plus, so plus 2 and 2 will be 4. 5 plus 4 lambda, 4 multiplied by negative 2 will give you negative 8, plus 5 is negative 3. So we get the answer here, minus 15, 4 and negative 3. Therefore, vector OA is given as, we can extend it, minus 15i plus 4j minus 3k. So this is the answer for the first part. It is again as required. It is as required. So first part is done for this. Let me show you this one. We need to show that OA vector is minus 15i plus 4j minus 3k. Yes, it is exactly like that. Now in the second part, find the other possible position vector of A. Now the next thing, you use the other value of lambda for sure. Lambda equals to 110 over 81, and we will get the other position vector. This is for second part. Vector OA. So here I will directly substitute this value. It will be 1 plus 8 into 110 over 81. And the next one will be 2 minus 110 over 81. And 5 plus 4 into 110 over 81. First answer is 961 over 81. Second answer is 52 over 81. And the third answer is 845 over 81. Therefore, this is the other position vector for A. We can extend it 961 over 81I plus 52 over 81J, and the last one is 845 over 81K. So this is second part is done. Last part of this question, the line L2 is parallel to line L1 and passes through O. Given that OA equals negative 15I plus 4J minus 3K, point B lies on line L2 where OB magnitude is given as 4 square root 10. Find the area of triangle OAB, giving your answer to one decimal place. Area of triangle could be found by using this formula: 1 over 2 times vector OA, magnitude of vector OA, multiply magnitude of vector OB, sine theta, multiply sine theta. This is the formula of finding area. Magnitude of OB is given, magnitude of OA could be found from here, but you need to find the angle theta. To understand how to find the angle theta between vector OA and vector OB, it is no need to draw even, but it will, I'm drawing this diagram just only to let you understand. And this diagram is not according to the scale, by the way, okay? It is just only to let you understand. Here, the line L2 is parallel to line L1 and passes through O. As I told you earlier, this vector is the direction vector. It is giving you the direction for line L1, this vector. Got it? And the second thing is given that line L2 is passing through the origin. Let's say this is the origin. This is the origin, and let me draw line L2. It is passing through the origin. Let's say it is going this way. And there is another line L1 whose direction vector is given here. That is 8 minus 1 and 4K. So I'm drawing roughly. It is not according to the scale. This is line L1 and the other line is parallel to this line L1. Maybe line L1 is somewhere here, or maybe it is on the top. That is your choice where you want to take it. So I'm drawing it here. These two lines are parallel. This is line L1. This is line L2 that is passing through the origin. This is line L2. And this is line L1. And direction vector is D for this one. Direction vector is giving the direction of this vector. And B is somewhere here. B is lying on line L2 and A is here. Let's say it is like that. For example, this line, point B lies on line L2 and point A is lying on line L1. And D is the direction vector that is giving the direction of this. Got it? And two lines are parallel to each other. Hopefully you understand how to sketch this one. Now if you join this one from O to A, this vector is in fact vector OA. And if you join this vector here with B, this vector is AB or BA, that is your choice. Got it? And you want to find angle theta. Actually this angle is theta and it looks like it is the acute angle. Got it? But we don't have vector OB. So instead of taking the dot product between vector OB and OA, we can take the dot product of vector OA. If you produce this vector forward like that, if you produce this vector forward, this vector is also theta. Like if you take the dot product of vector OA with the vector D, you will find the angle theta for sure. Hopefully you understand how you will find angle theta. This vector OA is given, this one, and D vector is given, that is direction vector. That is direction vector, that is 8, minus 1 and 4. And if you take the dot product of these two vectors, vector D and vector OA, you will find the angle theta. Got it? Now let's go and solve this question. For the last part, vector OA is given there, that is negative 15, 4 and negative 3. Negative 15, 4 and negative 3. This is vector OA. And vector D is given, it is 8, minus 1 and 4. 8, -1 and 4. Now if you find the dot product of these two vectors, you will find the angle theta by using the dot product formula, that is equals to OA magnitude vector D magnitude cosine theta. This is the formula for finding the angle. So cosine theta is equals to OA, you can make like this, OA vector dot vector D divided by the magnitude of these two vectors. Magnitude of these two vectors. Now plug in the values here. Vector OA is cosine theta will be equals to vector OA, that is -15 and 4 and -3, dot with vector D, that is 8, -1 and 4, divide by the magnitude of these two vectors. Magnitude of this you can write here 15 square, -15 square, plus 4 square plus -3 square. This will give you the magnitude of that. Unfortunately there is no space. Okay, let me make it. And then we take the magnitude of this vector, that is 8 square plus -1 square plus 4 square. Solving the numerator, here -15 multiply 8, give you the answer -120. Then 4 multiply -1 will give you answer -4. -3 multiply 4 is -12. Divide by solving these two. First square root, the square root of this one is 5 square root 10, and the square root of the other one is 9. Now you multiply them. In the numerator we have 136 over 9 multiply 5 is 45 square root 10. This is cosine theta. From here we will get the value for theta. So if you keep the negative sign inside, you will get the obtuse angle, but we need to find the acute angle. So ignore the negative sign. So it will give you the answer 136 over 45 square root 10. You will get the answer 17.1 degrees. Finally, in the next step we will find the area of triangle. Area of triangle is given as A equals to 1 over 2 multiply vector magnitude of vector OA multiply magnitude of vector OB and multiply sine theta. Plug in the values. Actually here is the magnitude. We have to find the magnitude of OA. We already found, that is 5 square root 10 here, right? Magnitude of OB is given in the question, that is 4 square root 10, and magnitude of OA could be found from here, right? From here. This value is the magnitude of vector OA, because you are solving the magnitude here. So it will be 5 square root 10. So plug in the values here. 1 over 2 multiply 5 square root 10 multiply 4 square root 10 multiply sine 17.1. We can simplify this one, left with 2 only. Use calculator, you will get the answer as 29.4 square units. So this is the area for the triangle AOB. Question number 6 is done. If you have any question, any doubt, please write in the comment box. Thank you.